Hi guys, welcome back to the HYSYS tutorials. Today we want to talk more about the heat exchanger. And in our last video, we actually had a problem. And what was the problem? The problem was that we could not get this effluent to cool all the way down to about 60 or so degrees, like we would have wanted, or 125 degrees, sorry. Yeah, so we would have wanted this effluent to go to 125 degrees C, and our reactor feed to heat up from 50 degrees C. Yeah, so that was a problem. So now we want to start solving that problem, right? We do want to solve that problem. And so how do we, go about solving such a problem? Well, probably one of the first things you can do. Probably one of the first things you can do is to take a look again at this Rigourous heat exchanger. Look at the Rigourous shell and tube side, and we look at under the Rigourous shell and tube tab, the model details. That should give us some kind of a clue as to what is going on. Okay, and then we have this new tab that describes the heat exchanger geometry, etc., etc. You can see, the heat exchangers tab is as such. Okay, so this is what is going on. You can see two very nice and straight lines, but you wonder why can't it go all the way down, right? So let's do it from the start. So we'll change this back to a simple weighted model. Okay, simple weighted model. And let it unlag itself. And HYSYS do its work. And we want to change it back to 50. We want to change this back to 50, and that will come out at 125. The reactor inlet will be 50, the outlet will be 125. So let's try to convert this to the Rigourous one again using the auto size function. So let's go. And it's saying 30 designs are okay, so you'll set the outlet stream conditions again. So let HYSYS do its converging. Let it run a few times. And again, you see that the heat transfer isn't really happening. You see that the material stream going in is about, the reactor inlet temperature is about 101 degrees C. Okay? We'll let it converge a few more times, or attempt to converge. And you'll probably, like the previous times, this recycle stream is going to just remain yellow and reach its maximum iterations without converging. Let's wait a little while more, and you'll see that it says maximum iterations reached, and the inlet is at 50 degrees C, the outlet is at 51 degrees C, but the reactor temperature is not at a temperature that we would like. So let's take a look first at the heat exchanger and look at the model details and look at the errors and warnings. It says we haven't put any fouling resistances. And this shell and tube, basically, basically there's nothing here. Alright. Okay. Let's go again to model details. Yes, this is the page I wanted to look at. Yes. So we take a look at you can look at this thing. You can see that there's a temperature starting from like 50 something degrees, about 50 degrees all the way up to about 107. But you can take a look at these warnings. This is the correct one that we should be looking at. Say you did not input any fouling resistances. Okay. In absence of adequate information to determine heat loads, it is anticipated or assumed that stream 1 condenses completely, giving an outlet temperature of minus 212.56 degrees C at pressure 7937.968 kilopascals. Oh, okay, so this warning is telling us that this heat exchanger requires some kind of initial gas in order to get the correct outlet temperature. So instead of this, we will need to do the sizing a little more manually. All right, so you can't use the auto size all the time. Sometimes you'll need to, as in this case, do it a little more manually. So let me show you what I mean. Let's go back to simple weighted. Let's let HYSYS do what it does and let it unlag itself. Okay. So the temperature should be back at where it is, and it converged within one iteration, which is good news. And then let's size the exchanger, and we can do it size interactively. So okay, what was the problem actually? Well, the problem was that there was no specified outlet temperature in this tab, this process tab, which also will be in this tab, this Rigourous shell and tube tab. You see this empty thing here, which I'm clicking on this little empty thing that I'm circling my mouse around. You need to specify that outlet temperature as an initial guess. So that outlet temperature was around 125 degrees C. Okay, and of course, well, we can also do other things such as input these fouling resistances. Okay, so this is the maximum fouling resistance that we can put. Any more and it'll just give you this red thing, and then it'll tell you like the range is between 0 and 0.002. So I'm just going to put 0.002 as the maximum. So the geometry will be, well, you want it with a removable cover sometimes, most of the time anyway. And you want to use stainless steel to prevent corrosion, SS304. Okay, but other than that, you can like specify the stuff. So we'll just let it size with these in mind. So it gives you some of the little iterations again, and let's see whether it actually works. You have a lot of OK designs now. Alright, which looks like good news. We'll just let the fella run and run. Okay, and we can look. You see that the outlet temperature is 125.05 and 249.99, which is exactly what we want. And the pressure drop is about 76 and 17 kilopascals, or 76 and 18 in fact. And there's hardly any warning. It just says unexpected orientation of baffle cut, blah blah blah. So it's just a different kind of baffle. But anyway, we got our good design with many passes. We have 5 shells in series, okay, 979 tubes and 1 pass. The heat exchanger costs about $1.3 million, as you can see at the bottom here. So we just put accept design and let it set the outlet conditions, and it should be able to converge very quickly this time. Alright, there you go. Now your heat exchanger is working correctly once you give it the proper initial gases. Alright, so that's the thing of how you debug. And if you're not sure, you can check this this thing I'm highlighting here. So you should be able to put a 125 outlet temperature over here, so that you give HYSYS a good initial guess to guess how much heat you actually want to transfer. So yeah, so that's how you do a proper heat exchanger sizing. And yeah, that's all for now. We have gotten a good pressure drop range, a reasonable pressure drop of about 100 kilopascal across the whole thing, across this plug flow reactor and this heat exchanger. And of course, if you want to include pipes, you can, but maybe in the next video I should show you more about pipes and all that kind of stuff. Alright, so thanks for watching. I guess I'll see you guys again in the next video. Thank you so much. Bye bye.